Welcome, Hornets, and thank you for joining me today. Today we're looking at the cosecant function, On the last video, all I was able to get through was the secant, so today we're going to be taking a look at the secant video, or the cosecant function, So last time we saw that the secant function, say y equals secant theta, had asymptotes that occurred at every pi over 2. So we had asymptotes occurring at theta equaling pi over 2 plus k pi, where k is an element of the integer set. Well, today we're going to take a look at our cosecant theta. And cosecant is actually a little bit easier than secant because we can clearly see that it happens at pi, 0 pi, 2 pi, negative pi, negative 2 pi, and it continues with 3 pi, etc. Which means that we're going to have to say that our asymptotes are occurring at k pi, where k is an element of the integer set. And just as we did with our secant, we're going to be using our asymptotes in order to find our information. So if I give you a function y equals a cosecant of b theta minus c plus d, we would start off by locating our d. This is our center line, y equals d. We're going to go up and down a value. So this has to be the point d plus the a value. This point down here is going to be d minus the a value. And these are where we're going to have our maximums and minimums, just like our secant. What is different is the location of the asymptotes. But that is all that is different. We're still going to locate the asymptotes. We're still going to have to go halfway in between. We're still going to have to find our center line and go above and below. We're going to have to plug in a value to see if we get negative 1 or 1, etc., etc., etc. So this is all going to be the same. The difference is we're going to set the pi k, our theta equaling pi k, equal to b theta minus c. Whereas before we set the b times theta minus c equal to the 1/2 plus pi k. Okay? So just keep that in mind. That's how we're going to deal with this. Let's go ahead and take a problem now and see everything in action. Ooh. Now remember, don't be afraid of these. There's nothing to fear. Regardless of whether we put a positive or negative, let's do a negative 3 cosecant of 2 theta minus pi over 4, and we're just going to go plus 1. So we're going to start off with our center line. Here's my graph. The center line is going to be a positive 1. And we're going to be going up and down 3. 1, 2, 3, down 1, 2, 3. So here is our center line. Our maximums and minimums are going to now lie on these two other dashed lines, either above or below. We're going to start off with our first asymptote, which would be at 0 pi. We're then going to find our next one at pi. That should be enough for us to finish the graph. So we take 0 pi and we set it equal to 2 theta minus pi over 4. We divide by 2 and we add pi over 4, and we find that pi over 4 is the location of our first asymptote. We're now going to take pi. Pi equals 2 parenthesis theta minus pi over 4. Pi over 2, we add the pi over 4. This will give us theta, and we find that theta is 3 pi over 4. Notice the distance that we went was a 2 pi, pi over 2. So we're going to want to keep that in mind. Now we're going to locate pi over 4. So let's do it as 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, going backward, doing pi over 4. Alrighty, so our first asymptote is at pi over 4. Second asymptote is at 3 pi over 4. So that was 2, here's 3. Let's do another 2. 1, 2. That's going to be 5 pi over 4. Let's just mark these down. 5 pi over 4. 3 pi over 4. Pi over 4. We know going back, that's negative pi over 4. And then negative 3 pi over 4. Let's see. Negative 1, 2, 3. Yep. Alrighty. So we now have asymptotes. We now need to find a middle point. Now we can start with any middle point we want. For example, we could start with 0 pi. We could start with pi over 2. Let's do pi over 2. Pi over 2 minus a pi over 4 is pi over 4. Pi over 4 times 2 is pi over 2. Oh, let's see. The cosecant of pi over 2 is a 1. Okay, 1 times negative 3 is negative 3, plus 1 is negative 2. We now know that at pi over 2, we're down here at negative 2. So pi over 2, negative 2. And our curve has to always move away from the center line. So it can't intersect with the center line. That means this next point right here, which we know to be, let's see, 3 pi over 4 plus 1 pi over 4 is pi. I put that in. I get 3 pi over 4. Let's see, pi. Pi minus pi over 4 is 3 pi over 4. Times 1/2 times 2 is 3 pi over 2. Cosecant is negative 1 at 3 pi over 2. That then multiplies to give me a positive 3 plus 1 makes 4, right where we expect. So this now becomes our pi, and we're looking at 4. Okay, that means that at negative pi over 2, if this was going down, let's go to 0 pi, it's got to be going up. So this point right here has to be 0 pi 4, whereas this point, going down, has to be negative pi over 2, comma, negative 2. And you'll notice we now have 2 periods of our cosecant. Ta-da! Our cosecant graph. And keep in mind that this is how we have to draw the cosecants. We start with our center line, in this case y equals 1. We went up and down 3. That's the 3 that we have here. Notice it's an absolute value. That is the equivalent of the amplitude of the sine that we would have graphed had we needed to. We don't have to graph the sine in order to get this. We can, but we don't have to. Remember, our sine curve is simply sitting right here, And there's no reason for us to have to graph this sine curve unless we feel we want to. I don't, so I'm not going to. Okay. Once we had our center line and our amplitude, we located our asymptotes, which is where the sine curve is going through the center line. We can do that by setting our asymptotes, known locations, 0 pi, pi, 2 pi, 3 pi, 4 pi, with our curve equation. So we're going to set 0 pi equal to our first equivalent of that 2 times theta minus pi over 4. We solved for theta and we found pi over 4. We then took the second known asymptote at pi. We set it equal to the 2 times theta minus pi over 4. And we solved for theta again. And we got 3 pi over 4. At this point, we could do it again. And we could put 2 pi, 3 pi, negative pi, whatever we want, all right, and just equate them. Once we have the locations of the asymptotes, halfway in between is going to be either a maximum or a minimum. It's going to be the equivalent to either pi over 2 or 3 pi over 2, where the cosecant is at its maximum or minimum. So we just plot them, plug them in, find out what we get, evaluate it, and plot the point. And that's how we graph secant and cosecant. I hope this has helped. If it has, please remember to click like. Excuse me. And I hope you have a very good and safe afternoon, and a wonderful evening, and a wonderful weekend, or whatever time it is that you are watching this. Be safe, be kind to each other. Remember, it's easy to be mean, so try to be nice to each other. It's the only way we can change the world is by starting from within, our perceptions of everybody else. Thank you very much. Cheers. Bye-bye.